Is the following series a convergent or divergent series? Remind yourself of the integral test. Integral test says for a series an, n starts from 1 to infinity, if f of n, which can be written as an, is positive, continuous, decreasing on the interval 1 to infinity, then the integral of f of x dx from 1 to infinity converges if and only if the series n starts from 1 to infinity, converges. So basically, you can convert your series into an integral and deal with the integral instead of the series itself. Let's take a look at this function. We need to check each one of these conditions one by one. Is it a positive function? Okay, you have 1 divided by 1 plus n squared. We can use Desmos and take a look at the graph, but in general, this guy is written as 1 plus x squared. So you can visualize this partly by, let me write 1 here, being positive. The graph of f of x equals to 1 divided by 1 plus x squared can be visualized as here you have the graph in part, not very precise, but we get the idea of the behavior of the graph. Okay, when x is equal to 0, you get 1 back. So the behavior of the graph is almost like this. So as you can see, the graph is above x-axis. It's part of the positive part of y-axis. So we can explain this. So the graph is in positive part of y-axis. So the first condition is met. It is positive. What about the second condition? Is it continuous? Take a look at the graph. The graph is continuous everywhere. Checking the graph or going back or analyzing the rational function 1 divided by 1 plus x squared. This is continuous everywhere. The domain of this function is all x values such that x is a real number. We don't have any restriction on the domain of this function. You are basically allowed to plug in any number that you like for this function. Or you can check the graph. Checking the graph, the function is continuous everywhere. There is no cut, there is no jump, nothing is identified for this function. So the second condition is also met. It is continuous. But is it a decreasing function? To check to see if it's a decreasing function, we need to take the derivative. 3. To check if this function is decreasing, we need to show that the derivative of the function is negative. I'm putting a question mark here because I'm not sure if this function is a decreasing function or not. And please pay attention. We are restricting the domain to 1 and positive infinity. We are not looking at the whole behavior of the graph from negative infinity to positive infinity. We are checking this on the interval 1 to infinity. So let us take the derivative. F of x is 1 divided by 1 plus x squared. The derivative of f, remind yourself of the quotient rule. P divided by q derivative is p prime q minus p q prime divided by q squared. This guy is equal to the derivative of 1 is 0 times 1 plus x minus the derivative of, okay, need a little bit of space, 1 plus x squared minus 1 times the derivative of 1 plus 2x squared, which is 2x divided by 1 plus x squared to the second power. So you have minus 2x divided by 1 plus x squared to the second power. But please pay attention here. On the denominator, this guy is always positive because it has exponent 2. My denominator is positive. On the interval 1 to infinity, this quantity is always negative. Negative on 1 to infinity. So what's the meaning of that? It means that the whole fraction is going to be negative. So it means that the derivative f prime is negative. What's the meaning of that for the function? You're going to say since the derivative of the function is negative on what? On 1 to positive infinity. So the function is decreasing. You can basically check the graph as well. So as you can see, your graph start decreasing, all right? F prime is negative here. Well, all of these conditions are met. We have a positive, continuous, decreasing function, so we can apply the integral test. So let us begin. Our main work just started. Since all 3 conditions are met, we can apply the integral test. So the series of 1 divided by 1 plus n squared, n starts from 1 goes to infinity, can be approximated using the integral of dx divided by 1 plus x squared. X starts from 1, goes to infinity. But I already know how to deal with this integral. This is basically inverse tangent. This is arc tangent of x. X starts from 1, goes to infinity. Okay, what was the arc tangent of infinity? What's the arc tangent of 1? Remind yourself of the graph of arctangent if you don't remember the behavior of arctangent. For arctangent, the graph was like this. Your arctangent behaved like this. You had 2 horizontal lines. One of them was pi over 2. The other guy was negative pi over 2. And when y is equal to arc tangent of x, it means that x is tangent of y. So when x goes to infinity, my x goes to infinity, where does the tangent go? Arctangent goes to pi over 2. So this guy is just pi over 2. What about arctangent of 1? All right. When you write down y equals to arctangent of 1, you're basically asking what angle gives me tangent of that angle equals to 1. But we already know that the angle is pi over 4. When y is pi over 4, tangent of pi over 4 is always 1. So you have pi over 2 minus pi over 4. If you do the computation, you get 4 pi. So you get 2 pi minus pi, which is pi over 4. So your integral is convergent to pi over 4. It means that your series is convergent to pi over 4.